do here is that we want to see this in a slightly different way, because we're going to be doing some manipulating today. And we want it to be based off of this guy, x plus b quantity squared. Okay, and so when you square this out, it's going to follow the same pattern. And let's just do it like this. So x squared plus 2 times x times b, if we follow that formula from above, plus b squared. Now I'm going to rewrite this just a little bit. So we have x squared plus, let's write this as 2b times x plus b squared. Just kind of putting the emphasis there on the b. And so we're going to use this idea to help us solve some equations that can't be solved by factoring and also can't be solved by using the square root property. Okay, so we're just going to go through an example. We're going to kind of formalize the steps here in just a moment. So, for example, if we were to take the equation here, x squared plus 10x, let's say plus 20 is equal to 0. All right, so in this case, this is a trinomial, and we've got x in 2 different spots, so this is not a square root property problem. If I just had this, if I just had x squared plus 20, yes, square root property all day long. But since we have 2 instances or 2 terms where we have the variable, we can't use the square root property. And instead, we want to try to factor. However, this does not factor. You could look for factors of 20 that will add to give you 10, but you just can't find anything that works. So we're going to do something else. We're going to set this up and we're going to manipulate so that we can use the square root property. So right now we can't use the square root property, but we're going to be able to by the time this is all over. And what we do here is we move the 20 to the other side, and there's a reason. You just have to trust me on this. So x squared plus 10x, leave some space, equals negative 20. What we want to do is that we want to put a number in here so that the left side of this equation factors, but we want it to factor in a very special way. We want this to factor as a binomial square, like this. And we can guess and check to get there, but we don't have to. We know exactly what this is supposed to be. Because if we compare this polynomial, this guy right here, to what we have up here, it's going to be pretty easy. So we're looking for a b so that I can do b squared and fill in the blank right over here. Well, look at this middle term right here. The 10 is supposed to match up with the 2b. And if these guys match up, that means that 2b equals 10, so b itself is going to be 5. And this b right here is the b that was inside the factored form. So what we're doing is we're going to put a number here so that we can factor. Now, if you look at the way the textbook says to do it, they would say find this number first and then factor. But I say let's just go ahead and factor at the same time that we're doing this, because the number that you're going to find here, in the process that you take to get there, you're going to go ahead and find out what the factorization is going to be anyway. So you do that by doing half of 10. Half of 10 is 5, so we do plus 5 inside here. And then 5 squared is the number that fills in the blank right here. So plus 25. Okay? So by having a 25 here, you now create a trinomial on the left side that factors. And it's not just that it factors, but it factors as the exact same 2 factors. If you were to say, or ask the question, what are factors of 25 that add to 10? You would say 5 and 5. The exact same 2 factors. And by having those exact same 2 factors, they merge into a square, which is what we have right here. Now you'll notice that I added 25 on the left side of the equation, which totally changes the problem. Unless I also add 25 to the right side of the equation. Okay? So remember, what you do to one side of the equation, you do to the other side. So I add 25 over here to create a square. I add 25 on the right side to maintain balance. So now we have x plus 5 quantity squared is equal to negative 20 plus 25 is 5. And now we're back to the problems that we were seeing at the end of the stream yesterday. You have a square equal to a number. So the way that we undo the square is that we use the square root property. Now remember that when we use the square root property, using the square root property, you're going to have that plus or minus come into play. Okay? So on the left side here, we just get x plus 5. On the right side, we get plus or minus the square root of 5 like that. And now you just finish solving the problem. We do that very easily by subtracting the 5 to the other side, like that. And x is equal to negative 5 plus or minus the square root of 5. And that's pretty much it. The key thing here is to remember that you are trying to create a scenario where we can use the square root property. Because at the very beginning, you can't use the square root property. This is a polynomial that doesn't factor, but we manipulate. Okay? We'll move the constant to the other side, and as long as this guy is a 1, it's pretty simple. You do half of the coefficient, you square that number, and that goes here to complete the square. Then you can use the square root property, and we're off to the races. So there we go. So now let's formalize the steps so that anytime you come across a problem like this, you can use completing the square. Okay? So, the first step for completing the square is to collect your variable terms on one side collect all variable terms on one side of the equation and move the constant to the other side. Okay? And you see that that's what we did up here. The first thing we did was to move the 20 to the other side. Okay? The second step is to divide all terms by the coefficient of x squared. Divide all terms by the coefficient of x squared. That is to make sure that we have a lead coefficient of 1. Okay? Now in this problem we didn't have to do that because it already had a lead coefficient of 1. Now once we do that, we move on to steps 3 and 4, which we kind of do together. Okay? Again, they are listed separately, but I say do them together. So step 3 is to add the appropriate amount to both sides that will create a perfect square trinomial. The amount that we add to both sides is going to be that piece that we have right here, that plus 25. But step 4 kind of gets tangled up in this, and step 4 is to factor factor the trinomial as a binomial square. Factor the trinomial as a binomial square, which is, again, is where we went from here to the factor form where we have a square. Because once we have a square, we use the square root property to finish. So use the square root property to finish. Okay. All right. So let's go on and do another example using these same steps that we have right here. All right, so you've got the steps in front of you or off to the side, I hope, because you're taking really good notes. I mean, why wouldn't you? And let's try this. Let's take x squared plus 14x plus 50 is equal to 0. Okay? You want to make sure that you go through this progression that we have for solving quadratic equations. The first thing you want to look for is, can we use the square root property? Meaning, do we have x only in one spot, and is it a square? Well, no, because we see two different terms that contain x, so the square root property does not come into play right now. The second thing we try to do is to apply the zero factor theorem. In other words, can this polynomial factor? You can try all you want to, but this guy just is not going to factor. Okay? So no, he doesn't factor. There's no way for us to find factors of 50 that add to 14. The third thing that we try to do is to complete the square. Now I'm going to tell you that completing the square is not always the best thing for us. Sometimes it leads us to fractions, which are not necessarily the best things for us to deal with. Okay? So here's what we're looking for so that completing the square is a nice, easy problem. You want this lead coefficient here to be a 1, and you want the middle coefficient here to be even. Because if the middle coefficient is even, then when we get to that part where we have to divide it by 2, we're going to be fine because we won't be creating any fractions. So the first step, we just had it in our notes, is to move the 50 to the other side. Alright, so we get x squared plus 14x, leave some space, and this is equal to negative 50, like that. So when you're completing the square, please make sure that you always leave that little gap right there. And you're going to have the same kind of gap showing up here on the right side. Remember, whatever adjustment I make here, whatever change I make here, I have to make the exact same change over here. Now we've got to figure out what that change is. So part of that is going to the factored form like this, and figuring out the number that goes in the factorization. Well, I think it's pretty simple, because you just have to take this number right here, the middle coefficient, and divide it by 2. So half of 14 is 7, so we go plus 7. So you divide by 2, and then you square that. So divide by 2 to get 7, square that, and we get 49. So by having a plus 49 right here, we now have a trinomial that factors with the exact same two factors, x plus 7 and x plus 7. Okay? That's the whole plan, the whole purpose for all of this, is to create something that's going to be the exact same two factors so that it becomes a square, so that we can use the square root property. That's the purpose. Like every step we take, there's a reason for it. Now, if I add 49 over here, I must also add 49 to the right side to maintain balance. Now, the 49 here goes into this factorization. This 49 over here, we just do the work. So this is equal to negative 1. And now that we have this, we now only have one instance where we see the variable, and so this is where we use the square root property. And you see, I'm going to keep using the same light blue pen whenever I do the square root property. And I hope that you have a special pen for the special things that we do in math as well. So we take the square root of both sides. We must make sure that we remember that when we are the ones who are introducing the square root to the problem, we must remember the plus or minus, which lines up with the fact that we have a square, so we expect to have two answers. Okay? So, this now gives me x plus 7 is equal to plus or minus the square root of negative 1 is I. Okay? So just like we had yesterday, we are now going to have equations where the solutions are non-real. It doesn't mean that we have no solution, it just means that they have imaginary pieces. They're not real, but they're still solutions. And we finish this by moving 7 to the other side. So x is equal to negative 7 plus or minus I. Again, this is an answer that we could not have gotten from factoring. And at the very beginning, we could not have gotten it from the square root property. So we had to manipulate and set it up so that we could use the square root property. I used to hate completing the square for some reason, but I don't know, it's fun. All right. Let us try another one. So 2x squared minus 24x all right, and I want to have, why's my mind going blank? Plus 56 equals 0. Okay? All right, so if we go through our progression, can we use the square root property at the very beginning here? Oh. The answer is no. Oh, what kind of pens do I use? Well, not that I'm trying to advertise or anything, but these definitely are my favorite pens. Kevin, been using them for quite a while now. These are Papermate Inkjoy Gel 0.7. They are a bit on the expensive side. They're not your normal cheapo ballpoint pens, but I really do like them. Some of the colors are not as nice, like there's a light green that doesn't work too well, but these are fantastic. The black ones are wonderful. Anyway, back to what we have here. Oh, no problem, Kevin. So the square root property does not work because we have two different instances of x. So that is no good for us. The second thing here is asking the question, would this factor? Meaning, can I use the zero factor theorem? And I can't. And now, you might be saying, how do you know you can't? Well, I know that I can't because I'm trying to set this up so that we can use completing the square. So it factors a little bit because you'll see there is a common factor for all three terms, but let me address that a little bit later. So instead, let us focus on doing completing the square. Okay? All right, so completing the square. The first step that we're going to do is to move the constant to the other side. Okay? So it means that 56 goes away. I don't really mean like it goes away, it doesn't disappear, it's not gone forever. It's just on the other side of the equation. So equals negative 56, like that. So that was the first step. And we can, I hope that wasn't important. So look at our steps real quick. Collect all the terms, all variable terms on one side, constants on the other side, done. The second step is to divide all terms by the coefficient of x squared. Okay, so here the coefficient of x squared is 2, so I need to divide everything here by 2. Now you may be saying, wait a minute, you didn't do that in the last problem. In the last problem, the coefficient of x squared was 1. So if I divide everything by 1, that doesn't change anything. It's still going to be a 1. But here, we divide everything by 2, and we have x squared minus 12x, still keep the gap right here, equals negative 28. Okay? So remember, we've got this gap that we're going to be filling in. Now, it doesn't really matter what number's on the right side. I don't care about that guy at all. I care about what's going on over here. I'm supposed to be rewriting this to be a binomial square. And again, it's not a guessing game. It's all about playing the little trick, which is to divide the 12 by 2. So half of 12 is 6, so minus 6. Divide by 2, you square this number, and that gives you the plus 36 that goes here. And it really doesn't take too much to check this to see that it does work out right. If I ask you what are factors of 36 that add to 12, you would say 6 times 6. And that's what we have there, but it's the same two factors, which is, again, why it's a square. If I add 36 on the left, I have to add 36 on the right side. So the left side factors, the right side becomes positive 8. And now we've gone from having 2 instances of x to just 1. And so now I can apply the square root property. Do that on both sides and make sure that you remember plus or minus. Okay? So by taking the square root over here, it's the inverse operation of the square. So we are left with x minus 6 on the left. On the right side, we want to factor 8 if we can, so that one of the factors is a perfect square. Okay? So 8 can break down as 4 times 2. Remember, these guys are both their own individual square roots. We can take the square root of 4 to get 2. The square root of 2 has to stay exactly as it is, so that's the square root of 2. And don't forget about the plus or minus. So plus or minus. We're one step away from finishing the problem, and that step is just to move the 6 to the other side. So x is equal to 6 plus or minus 2 square roots of 2. And that's it. There's nothing more that we can do here. I believe we talked about this yesterday. You could try to separate this. And if you separate, you could say that x is equal to 6 plus 2 square roots of 2, or x is equal to 6 minus 2 square roots of 2. But even if I separate those guys, there's not anything else I can do. The 6 cannot combine with that irrational square root, so it just stays as it is. So leaving it like this is perfectly fine. And if you're doing this in my math lab, you know that that's going to be an okay response, as long as they give you the option of doing plus or minus. Okay. Now these guys can get ugly. Okay. So I think we should get ugly. Let's see what we come up with. Excuse me. Make sure that you are all staying hydrated out there. Although I will say today has been a very cool day. So if you haven't had a chance to get outside, do so. Go take a nice little walk. Make sure that you are maintaining, good social distancing practices. And enjoy the lovely afternoon that it is. All right. Let's see what happens when there is no preparation. If I take 2x squared plus 3x minus 4 is equal to 0. This is how I This is how I lose people. But we're going to get through it. It's going to be messy, but there is a point to this. So if we work through this problem, we think about the ways we have for solving this. We could try to use the square root property. However, you have two instances of x, so that's not going to work. The next thing we would try to do is factoring, trying to apply the zero factor theorem to this problem. Well, we do a quick little AC method check on this. 2 times 3 is 8, and then we try to find factors of 8 to subtract to 3. Unfortunately, we get nowhere on that. And all we know right now is completing the square. So let's see what we can do there. Here's what you need to understand about completing the square. We can always complete the square. It's just not always fun. And this is going to be one of those not so fun problems. Let's go through the procedure. Follow those steps so you can see how do we do this. Okay? The first step is to move the 4 to the other side. So sorry 4, you are in the way. So 2x squared plus 3x equals 4. Now I have a gap here, but I'm not ready to put that little blank to fill in yet because I don't have a 1 here. I've got to make sure that lead coefficient is 1. So this is where I divide everything by 2. Everything by that lead coefficient. Oh, this is fun, right? You see what I've done? You see what kind of monster I am? I've created fractions. Oh well. X squared plus 3 halves x equals 2. I only created one fraction. It could be worse, right? So now we have this gap to fill in on each side. Not only that, but we've got to figure out what goes inside this factored form. So let's see what that is. So remember what we were doing before. We have to do half of this. Now it was fine, let's see, in the last problem we had 12. So half of 12 is 6. Before that we had 14. Half of 14 is 7. Not a problem, as long as that middle coefficient is even. If that middle coefficient is anything but an even number, it gets messy and we have fractions. Well, and we already have fractions. But to figure out what goes here, just do some thinking off to the side. So what we often say is that we're going to divide by 2 and square it. But another way of saying divide by 2 is to do half of it. So if I do half of 3 halves, that's just that product of those two fractions, and we get 3 over 4. Okay, so that's half of it. That wasn't too bad, was it? No, of course not, Mr. Craig. You're always right. So it's plus 3/4 that goes there. So to figure out what goes here, it's all a matter of squaring this number. Don't worry that it's a fraction. Fractions are numbers too. And in order to square a fraction, you square the numerator, 9, and you square the denominator, 16. See? That wasn't too bad. And now we add 9 over 16 to the other side to maintain balance. Okay? Again, it may take more time because there are fractions involved, but it's not impossible. Now over here we got to figure out how to do that addition. Well, again, this is why we have room off to the side so we can scratch things out. Alright, so I need to do 2, this is really 2 over 1, plus 9 over 16. I need to get a common denominator, which is 16. Alright. So we get 32 over 16 plus 9 over 16, and altogether 41 over 16. Yeah, okay. I mean, again, it's just a number, so please don't let that throw you off. So 41 over 16. Well, we finally got where we want it to be. We have x in just one place, and so now we want to take the square root of both sides. Use that square root property. So take the square root of the left side and of the right side. Don't forget your plus or minus. On the left side of the equation, we just have x plus 3/4. On the right side, plus or minus. Now we can separate this into two smaller radicals. If I look at the square root of 41, I can't do anything with that. 41 is prime, so he stays as the square root of 41. However, when I look at the denominator 16, the square root of 16 is 4. So we were able to simplify just a little bit. And now we're going to move that 3/4 to the other side to say negative 3/4 plus or minus the square root of 41 all divided by 4, like that. Now this is kind of an okay way to leave your answer, but we can clean it up and say negative 3 plus or minus the square root of 41 all over their shared common denominator of 4. That is the cleanest way of writing your answer. Now, here's a really funny thing about all that we did right here. There's an easier way to do this. A way that we can solve this quadratic equation without having fractions running around in every single step. So, what I'm about to show you is not the end-all be-all for solving quadratic equations. It is a method to use when nothing else works nicely. Here's what I mean. When you look at your progression that we talked about up here at the top of the page, the square root property, if you only have one instance where you have x, you're going to use the square root property. And this, we're talking about if you have an equation that's quadratic. If not, you try to factor. That's what the zero factor theorem says. Factor. If factoring doesn't work, now you're in this weird realm where you want to try to complete the square. If you're going to complete the square, there are certain things that you want. You want to have a lead coefficient of 1, and if you don't, get it to be 1, which is what we did here by dividing everything by 2. But then you want this middle coefficient to be even. And as we mentioned before, if it's even, it's easy to do half of that guy and then square the result. Otherwise, you have something like this. You've got either an odd number or you have a fraction, and doing half of that is either going to create a fraction or create an even worse fraction. But there is a fourth way of solving quadratic equations. And this is when nothing else works out nicely, and it's the quadratic formula. Okay? A lot of you remember this, but I want to make sure that we are not abusing it and overusing it. Okay? So, solutions to any quadratic equation. Remember, a quadratic equation is ax squared plus bx plus c equals 0. So solutions to any quadratic equation can be found by using the quadratic formula. And here's what the quadratic formula says. It says your solutions given by x will equal negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So that's your quadratic formula. It looks messy, but don't worry about it. You didn't have to come up with the formula. You could have, but somebody else already did. And the reason this exists is because somebody a long time ago took this standard quadratic equation, they kept the a, the b, and the c exactly as they are, and they completed the square. That means they moved the constant to the other side. They divided everything by the lead coefficient of a. They put in the missing term, they factored, they used the square root property, and you come up with this. Now what I'm going to do is I'm going to take the very last problem that we did and now see what happens if I were to use the quadratic formula. Okay, let's see if it's different. Let's see if there are any similarities too. Alright, so the problem that we just did, we had 2x squared plus 3x minus 4 equal to 0. If we're going to use the quadratic formula, we have to accurately identify the a, b, and c. So the a is the lead coefficient, which is 2. B is the coefficient of the middle term, 3. And c is your constant. Now notice that when we identify a, b, and c, there are no x's. We're picking off the coefficients, and we're just pulling off this constant term. Now, if you have a quadratic equation that leads with a negative, my suggestion is that you take one additional step and you multiply everything or divide everything by -1 so that you lead off with a positive. If you lead with a positive, your work is going to be a lot easier to do. Now, that's a, b, and c. To use the quadratic formula, you write the quadratic formula. I don't care what anybody else says. Anytime you have a formula that you need to use, you write the formula. So, you know, it's almost like you can sing it, right? It's like that little catchy tune, right? X equals -b plus or minus the square root of b squared minus 4ac all over 2a. There you go. I feel like I've heard that tune somewhere before. So, write it down every time you use it. Now plug in. X equals, okay, we got a big fraction here, -b, so b is 3, so that's going to be -3, plus or minus square root. All right, so I've got to do b squared. If b is 3, then b squared is 9. Now here's what I do. I take the -4ac, I take this guy off to the side and I work it out. -4 times a times c, which is going to be -4 times a, which is 2, times c, -4. And when I work all this out, -4 times 2 times -4 is a positive, make sure you get the sign right. 4 times 2 is 8, times 4 is 32. So that number goes back inside here, plus 32. All divided by 2a. Since a is 2, you're going to do 2 times that guy, and we get 4. So we plug in the numbers, do a little bit of arithmetic off to the side, and now we clean it up. X is equal to -3 plus or minus the square root of 9 and 32 is 41, all divided by 4. Wait a minute. Let's see. Ah! That's the same thing we had last time. Check this out. It's the same answer. But notice the amount of work is quite a bit less. That's because we had fractions with completing the square, so it added a lot of extra steps, a lot of things extra on the side we had to take care of. The quadratic formula recognizes what's going on, and it makes it nice and easy for us. But please understand, this is not the first thing that we jump into. So please don't always do this at the very beginning. Okay, let's do another example, and then we're going to run through several examples and really talk about how do I know which method to use. How can I make it nice and easy? And when do I need to either complete the square or use the quadratic formula? For example, if I take 5x squared minus 3x plus 7 is equal to 0. We're going to go through our progression and make sure we understand why we would use a particular method or why we wouldn't use that particular method. All right. So let's work this out. The first thing we would try to use is the square root property. Now, you're only going to use the square root property if you only have one instance of x, and that's either going to be contained inside of a square or it's going to be x squared itself. But I've got two instances of x, so no square root property. The second thing I'm going to try to do, recognizing that this is a trinomial, is I'm going to try to factor ZFT. Let's see, 5 times 7 is 35. Are there factors of 35 that add to 3? No. No. We can't get as small as 3. So it doesn't work. Then we try to do completing the square. What are we looking for completing the square? Well, first of all, we want this lead coefficient to be a 1. It's not 1, but we can get it to be 1 by dividing everything by 5. We can do that, but if we divide everything by 5, we are now entering into the realm of fractions, and you probably don't want to do that. We can, but there's no point in us doing it. It just makes it more difficult than it has to be. So I'm going to say, no, this is not set up, and it won't be set up very well to complete the square. All right, so the last tool in our bag is the quadratic formula. This is when nothing else works. So, quadratic formula. In order to use the quadratic formula, you have to have everything on one side of the equation, and 0 has to be on the other side. If things are on different sides of the equation, you've got to put them all on the same side first. So we have it set up right. A equals B. Excuse me, A equals 5. B equals -3, and C equals 7. So the quadratic formula. Sing it with me at home if you would like. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. You guys sound so wonderful. All right, so let's start plugging in what we have. X is equal to -b. Well, now notice that b is already negative, so you're going to do a negative. So that's 3 plus or minus. Now, this is where students get really thrown off because they don't pay attention to their signs, and especially whenever they go to the calculator, they're not paying attention. So on the calculator, if you just go, well, I just want to check my work just to make sure, if you type -3 squared, it's going to tell you -9. Now, we know better than that. Whatever you plug into this guy, whether it's a positive or a negative, once you square that, you're going to get a positive. Because see, here's what you meant to type. Parentheses, -3 squared, because you're squaring that entire number, and you get +9. Be careful with your signs. All right, so we get 9 minus 4ac. All right, so that is -4 times a, 5, times c, which is 7. All right, so this is going to give me a negative number. 4 times 5 is 20. 20 times 7 is 140. And this little guy goes in here, so minus 140. Please pay attention to what I'm doing, is that I'm including the negative, that subtraction, I'm including that in the product over here. So then I just copy the number over. And this is all divided by 2a, so a is 5. 2 times 5 is 10. Now, we just need to clean up our work. So x equals 3 plus or minus the square root. 9 minus 140 is negative 131. And with that square root, we're just going to try our best to simplify this. Well, 131 is prime, if I'm not mistaken. So we can't factor that guy, but there is a negative. So there is one bit of simplifying that I can do, and that is to simplify out the imaginary unit I. So this is what we're going to have for our final answer. 3 plus or minus I, square roots of 131, all divided by 10. This is an answer that you could have gotten from completing the square. It just wouldn't be a lot of fun. But you can totally do it. Alright, hopefully so far so good. Hopefully it's all the stuff that you remember from the first part of the semester. And now we're just going to try to mix it up. Put all the stuff together that we've learned so far with solving quadratic equations and just, take it to the next level. All right. So let's solve 5x to the third plus 4x squared plus 35x plus 28 is equal to 0. Are you telling me there's no audio? Really? Well, it looks like there's audio that's picking up. Make sure that you haven't... Okay, so you're still hearing it. Maybe you did accidentally hit the mute button. I don't know. I'm having the biggest issues getting everything set up and working right every time. So, anyway. Alright, so with this problem, please note that there are a ton of terms here. You've got 3 different instances of the variable x. So we know that this is not a square root property problem. But this is still a polynomial equation. So we can't use the square root property, but we can use not completing the square, I'm out of my mind, factoring, right? So let's try to factor this. In the first group right here, do we have a common factor? And the answer is yeah, we sure do. There's a common factor of x squared. Factor that out, and we have 5x plus 4. Then we move on to the second group, and we hope that we have something that is common between those guys. Now notice I had a 5 left over here. Hopefully 5 goes into 35, and you see that it does. It goes in there 7 times. So 7 goes into 35, and it also goes into 28. So it's a neat little way of kind of working the system to be in our favor. So the common factor is 7, so factor that out, and we have 5x plus 4 again. Wow, that is super convenient. It's like somebody knew what they were doing when they made up this problem. Alright, so since these guys are exactly the same, we're going to factor that out front, just like we would do with factoring by grouping. And now we have x squared plus 7 over here. Now I want you guys to understand that so far we haven't done anything with completing the square, we haven't done anything with the quadratic formula, because there's been no need and no setup where we could do that. This is a factoring problem first and foremost. So using the zero factor theorem would then say that you would set each factor equal to 0. So 5x plus 4 is equal to 0. Or x squared plus 7 is equal to 0. Look at these as two smaller, separate equations. You don't need to worry about the big 4-term polynomial at the beginning. Worry about these two small guys right here. So to solve this guy for x, you know that you would need to subtract 4 and divide by 5. Okay? Again, if you want to take each little step to get there, you can. We've been through a lot, so I hope that we can go straight to that answer. Over here is where you see you've got x squared. But this is the only term that has x. So this is one of those examples where you want to use the square root property. So x squared equals, you subtract 7 to the other side. Now that you have the x squared by itself, you want to undo the square by using the square root property. So do the square root on both sides, plus or minus, like that. And x is equal to plus or minus. It's very tempting to say 7i, but we need to remember that the square root of 7 is not 7. The square root of 7 is not a perfect, it doesn't contain a perfect square factor. It's only this negative that's going to come out as an I, and the 7 stays inside like that. Now before we move on, I want to make sure we understand something. The original polynomial equation had a degree of 3. And so that tells me how many solutions we would expect to have at the very end. A degree of 3, we should get 3 answers. We've got negative 4/5. We've got plus or minus, so that's 2 extra answers, plus or minus I square roots of 7. So we get all 3 of the solutions that we're looking for. Isn't that wonderful? Okay. Let's try 9x squared and that's going to give me a problem. 9x squared minus 22x plus 8 equals 0. All right, let's go through our progression, making sure that we understand when to use what method. Okay, it's not a guessing game. We are smart and we progress through this logically. We think. First of all, can I use the square root property? Well, no, we can't use the square root property because we have x in 2 different terms. So that's a no-go. The second thing we look for is the zero factor theorem. Can I factor this? Now, I have way too many students who say, nope, we can't factor. We've got to go to the quadratic formula. Well, take a time out and let's see. If I do the AC method, A times C is 9 times 8, which equals 72. Can I find factors of 72 that add to 22? Well, here's what we're going to do. If you're not sure, you can go through the process, go through all of the factor pairs, see about 1, 2, 3, try all those combinations. You can do it the long way by typing it into your calculator. But remember the trick that we showed you last week? So what we showed last week is that you can go to y equals, and if you're trying to find all of the factors of something, type in that number, 72, and then divide by x. Once we do that, we go to the table, and you see up here that you get 1 in 72. Yeah, I better write these down. I don't want to forget anything. All right. So 1 in 72, 2 and 36. Keep in mind that we're trying to find numbers that add to 22. All right, so go down. That's 3 and 24. Those guys add to 27. We're getting closer. 4 and 18. Oh, wait a minute. That's the combination that we're looking for, right? 4 and 18 will add to 22. So since we do have a combination that will add to 22, the 4 and the 18, then we know that this guy factors. And now it's just a matter of factoring this guy. And so what we like to do with the 4 and the 18 is that we use those guys to rewrite that middle term. So this becomes minus 4x minus 18x plus 8 is equal to 0. Now, again, as we've mentioned before, I did 4 and 18, but you could just as easily have done 18 and then 4. The middle step for factoring by grouping would look a little bit different, but at the end, we should still have the exact same answer. So for this first group, the common factor for 9x squared and 4x is x, and so we factor that out. We have 9x minus 4. In the second group, again, pay attention to your signs, you have a negative, and the common factor for 18 and 8 is 2. Factoring that out, we are again left with 9x minus 4. Okay? And just as we expected, just as we knew this was going to happen, we have a common factor. So 9x minus 4 times x minus 2 is equal to 0. And from here, we've got it factored, and now we can use the zero factor theorem. So 9x minus 4 is equal to 0, or x minus 2 is equal to 0. Solving this, x is equal to, let's see, we would add 4, divide by 9, and for the other factor, we get the solution x equals 2. And there we have it. So the square root property didn't work, but we could factor. Now I know a lot of times students say, I don't want to factor, I just want to use the quadratic formula. Ooh, you can use the quadratic formula, but it's not going to be a lot of fun. But you know what? You may not trust me, so let's do the exact same problem using the quadratic formula. So I want you to compare and see how things go when we go quadratic formula on that guy. I really don't want to do this, but I feel like I've got to prove a point. Okay. So if I take 9x squared minus 22x plus 8 is equal to 0, we identify that a is 9, b is negative 22, and c is equal to 8. Again, the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, plug in what we have. So x equals, here's our big fraction, negative b is going to be positive 22 plus or minus, all right, b squared. I'm sure that you guys all know that when you square 22, you get 484, right? Yeah. Well, you got a calculator anyway. So that's 484. Aren't you glad that you went for the quadratic formula? I'm sure you were. All right, so that's negative 4 times a, 9, times c, 8. So when you multiply this, you end up with negative 288. So put that in here, minus 288. And all over 2a, so 2 times 9 gives me 18. Why did I do this? What am I doing? X equals 22 plus or minus, let's see, 484 minus 288, 196. And if students even get this far, this is where they just say, you know what, that's got to be good enough. I'll put a square, just, box this, and it'll be good. No, keep on going here. So x equals 22 plus or minus, please make sure you understand that the square root of 196 is 14 all over 18. Now, again, students may take this time to stop. Notice, you have nothing imaginary and you don't have anything that's radical. If there's nothing radical, no square roots, nothing imaginary, that means you're not done. That means you have to take this and you've got to separate it into your two possibilities. So x is equal to 22 plus 14 over 18, or x is equal to 22 minus 14 over 18. Man, if only we had just factored, that would have been so much easier, right? So 22 plus 14 is 36 divided by 18, which equals 2. And down here, 22 minus 14 is 8 over 18. 8 over 18 reduces to 4 over 9. So here are our two solutions. And these two solutions are the same things that we had when we did it the first time, right? 4 over 9 and 2. But notice, the largest number that I got when I did it this way was 72. And then after that, it was pretty nice and easy. Look at what you've done over here. Just look at yourself. Are you proud of this? 484 and 288? Gross! This is why we have the progression. This is why we try to see about factoring. This is why we do that AC method to see, is it going to work for us or not? So, yeah, that could have been a lot better for us. Actually, it was a lot better for us because we did it better the first time. All right, let's look at x to the fourth minus 5x squared minus 36. All right, so this is a trinomial. You see, you've got two terms with x's in them, so it's not a square root property problem. Let's try to factor this. Okay. Now, we saw a problem like this last week when we were reviewing factoring. If you have x to the fourth, we kind of expect this guy to break down evenly as x squared and x squared. And this is a constant term, and we expect this guy to break down. Hopefully we can find factors for 36 that will subtract to 5. And we do 9 and 4. And of course, using the right signs, it's going to be negative 9 and positive 4, like that. All right. Well, you know what? I said solve. I didn't even set this up as an equation. So let me fix this real quick. I want you to think about what we have done in the past. There we go. This is what I meant to do, right? Because I don't make mistakes. So if I turn this now into an equation, x to the fourth minus 5x squared minus 36 equals 0, like that. And then you look at this factorization, x squared minus 9 times x squared plus 4. We factor, we use that zero factor theorem, which is going to say that x squared minus 9 equals 0, or the other factor, x squared plus 4 equals 0. And then from here, we recognize that these guys are both square root property problems. Okay? So for this one, move the 9 to the other side, and then take the square root of both sides using that square root property, like so. And don't forget the plus or minus. So x is equal to plus or minus 3. Square root of 9 is 3. Over here, we move the 4 to the other side, so x squared is equal to negative 4. Take the square root of both sides. Don't forget the plus or minus. And now we have that x is equal to plus or minus. The square root of 4 is 2, but the negative is going to make that become I. So you get plus or minus 3, and plus or minus 2i. We were expecting to get 4 solutions because that's what the degree was. You get 2 here, the plus or minus, and you get 2 more over here with the plus or minus. So altogether we have 4 total solutions. Alright? Alright, I think I got one more in me. How about you guys? Now this may or may not have been a problem from one of your exams. All right. X squared, excuse me, x squared plus 18x plus 117 equals 0. Okay? So we do not jump into things when it comes to these problems. We go through it systematically. We think about the process and the progression. The first thing that we have to try here is to see if this guy is eligible for the square root property. And since I have 2 terms that contain x, the answer is no. The next thing I try to do is to see if this guy factors, meaning use the zero factor theorem. You can search all that you want to for factors of 117 that will add to 18, but you will never be successful. The third method that we've talked about is CTS, completing the square. Now, in order for completing the square to be nice and easy for us, we want the lead coefficient to be 1, and it is, and we want the middle coefficient to be even, and it is. So we want that middle coefficient to be even because we know part of this process is to divide by 2 and square it. All right, so completing the square looks like what we want to do. You do not want to jump into the quadratic formula on this. This is why we have that progression. It's going down in a list of easiness. If this doesn't work, go to the next one, which might be more difficult. The next one might be more difficult, and so on. The quadratic formula is, we use that at the very end. Okay? If nothing else works, quadratic formula. All right, so completing the square, as we've seen before, says to first move the constant term to the other side. So equals negative 117. The second step says to divide everything by the coefficient of x squared. The coefficient of x squared is, it's already 1, so I don't need to do anything extra for this. So this next part is where I'm doing those 2 steps at the same time. I'm trying to figure out what's going to go in the gap right here at the same time that I'm trying to figure out the factorization. Easy way to figure that out is to do half of this number. Half of 18 is 9, and then 9 squared is 81. So in order for us to get to the factorization, we needed the 81. And when that factors, you would have x plus 9 times x plus 9. But again, I kind of skip the 81, and I just go here. I find the 9, I do half of that coefficient to get 9, I square that to tell me what goes in the blank. And to me, that's a little bit easier way of working it out. But remember, what you do on one side, you do on the other side. All right, so the left side factors, and the right side, negative 117 plus 81 is negative 36. And now we've set this up, we have finished completing the square, and the reason we complete the square is so that we can use the square root property like this. Take the square root of both sides, remember your plus or minus, and now x plus 9 is equal to plus or minus. We do the square root of 36, which gives us 6. The square root of a negative yields I. So again, we complete the square so that we can use the square root property, and now we finish getting x by itself here by subtracting 9 to the other side, so negative 9 plus or minus 6i. And there we go. Now, if you want to, try solving this problem using the quadratic formula, and you'll find out that the numbers get really messy and ugly and really kind of unnecessary. So I think this is a much simpler way, and we get that just by following the progression that we've talked about. All right, last problem. All right, so 5 plus 3 times the square root of 2, not square root, I don't know where I get the square root from. 5 plus 3 times the quantity, I need to go to bed. 2x minus 9, quantity squared, is equal to 16. You know what? I better change this up just to make things a little bit nicer for us. I'm going to make that negative 17. Negative 16. Good grief. It's been a long week, right? Oh, what was that? It's only Tuesday. We're in trouble. All right, so let's go through our progression and let's see what we get here. The first thing we want to try here is to look for the square root property and see if that's something that applies. All right, for the square root property to apply, we have to recognize that we have a square, which we do, and that we only have one instance of the variable x, and that's it. This is the only place where you see x, which means this is a fantastic candidate for the square root property, which means we just have to work on peeling away the layers until only x remains. And we're going to start off by subtracting the 5. Please do not combine 5 and 3. Okay? The 3 is connected by multiplication to the quantity 2x minus 9 squared. The 5 is not connected to the 3, so move him to the other side just by subtracting 5. And so now we have 3 times the quantity 2x minus 9 squared is equal to negative 21. The next step to get the x by itself, you can't deal with the 2 or the 9. You have to deal with these outside guys. And the one that we're going to get rid of first is the 3. Okay? Notice that the square is applied to this entire group, not to the 3. So the 3 is free to move away. So the inverse of multiplying times 3 is to divide both sides by 3, like that. All right, so we have 2x minus 9, quantity squared equals -7. Now we can address the issue of the square. The square is the big guy who's in the way. And so now we use the square root property. Plus or minus, like this. And so now on the left side we just have something that's linear. And on the right side, the only thing we can do is take the negative and pull that out as an I, because 7 is not a perfect square and he stays inside like that. Alright, 2 more steps and we're done. We add 9 to both sides. So 2x is equal to 9 plus or minus I square roots of 7. And then we can finish by dividing both sides by 2. And there's no more simplifying that we can do. 9 plus or minus I square roots of 7, all divided by 2. If you try to separate this, one with the plus and one with the minus, it's not going to do you any good. Nothing's going to change here. So that's it. We can box that and we can move on. Okay? So, that's it. I want to thank you guys for stopping by and being part of the stream. I do want to remind you all where you can find me. So, just need to look up there. Find me on YouTube, Twitch, or Twitter. And I hope to see you around. I'll keep streaming here at 3 o'clock in the afternoons here Central Time on Twitch and uploading the videos later on to YouTube. So, hope you all have a great afternoon. Take care.